connect OT legacy systems, so operational technology systems, sit in a building, control your lights, your elevator, your heating and cooling, to the cloud in a highly secure and scalable model. We've been going now for 4 years. We closed Series B funding in September last year. Some of the investors were introduced before. There's 2 new investors and they're critically important. Honeywell Ventures invested into us, and John Chambers invested into us through JC2. So John saw there's a huge opportunity about connecting systems in an OT world, operational technology. So when I use OT, it's operational technology, not IT, and making it highly scalable. So this isn't something that Cisco has tackled. They haven't been able to solve that problem. So we've really focused on that software-defined WAN to securely connect that. The other part of Honeywell coming in is Honeywell has a huge install base around the world. They know that on the hardware level, it's becoming a relatively commoditized part. So for them to function and have competitive advantage in the marketplace, they have to build out their cloud-based applications. What they're missing is that connection piece in the middle. That's what we solve. So we don't do something big, we do something very small, but we do it incredibly well. So today, IIoT, or digital transformation, really is at a defining point. Many of our customers and different segments of the market, they know that they need to do something around digital transformation. They need to take data, they need to turn it into some sort of value. That could be improving utilisation, optimisation, productivity, reducing costs, scale, producing different business models. The reality though is the vast majority of businesses today do not have the resources in-house to do it, and they don't even have the roadmap for how to do it. From a cyber security perspective, most of those operational technologies that are in place that they want to get data out are totally unsecure. I spent 12 years of my life at Siemens. When we built systems, PLCs, SCADA systems, control systems, they were designed to go into a building and to control that building, into a manufacturing floor, into an oil and gas field. They were never designed natively to be cyber secure. It evolved over time, start to say, can we connect it up? So you can think about the literally millions and millions of systems that are out there in the world today. You have to go through and put firewall in place, you have to put a switch in place, you have to build infrastructure around it just to secure it. So what we've seen, and you think about our customers, we go to market in 3 different verticals. The built environment, so buildings like this, the industrial, so PLCs, manufacturing, infrastructure, and then energy, so oil and gas, renewables, resources, power generation distribution. All of these challenges that are up here are common across the board. What we have seen in recent times is a strong drive towards compliance and governance from a board, from investors, from the leadership team of the company to say, are my facilities, are my assets secure? And that's really has driven a huge need for us, a huge demand for us recently. Another part that they're saying is, how can I unify and safeguard all of those assets today? So the first thing is, am I protected? No. How do we do it? If you now think about people starting to access those systems remotely, a lot of technicians, and I'll use my Siemens example, is that when a Siemens technician wanted to change PLC code or control code, they would either go in through a portal that they had open or a VPN that was provided, and then they would provide code changes to it. Within that, the owner of the asset would invariably not know when the person went in, what they did, how often they were going in. And so one of those things about that remote access is a significant problem. You think about this elevator tonight, you could have an Otis technician who comes in and accesses that if it is open and connected to the network, and so change code, and then suddenly you can't go out. Now that is a life safety system. It's an extreme situation. They're not going to do that. But those are the possibilities. The single thing of glass. It's a common term now coming through certainly into the Honeywell world. How do I have a single pane of glass into all of my infrastructure and assets that are out there? A big one, and this is where we're very strong and really invest heavily, is analytics at the edge. So you can see from robotics examples today, there's a fair amount of edge compute that is going into that device. It's either mobile or going around, or it's fixed in there. Or it could just, again, be the building example. But how do I deploy the analytics at the edge without sending somebody to site or to that asset to change it? Again, you think about the Honeywell example of millions of sites around the world that are connected. They need to send, today they need to send a technician out, potentially even put a server in place to do it, and then manage the server and manage the patching, the upgrades, etc. So those are the big challenges. So here's a diagram of what we do, and I'll try to explain it as simply as we can. Think about existing assets that are out in the field, or new assets are down here, IoT assets. We place a hardware unit in there. But that's not our hardware unit, we're totally hardware agnostic. Take, for example, a Dell 5000 gateway, which is a common off-the-shelf edge compute device. That device then has our operating system put on place. Now this operating system is totally secure. You cannot plug anything into it. There's no command line interface at the edge. It's incredibly locked down. As soon as you start to tamper with it, it shuts down and won't come off again. That's our operating system. It's our IP that we're brought into it. We then have three boxes there: network, security, and compute. Our core DNA of the company is security engineers. This is a hyper secure environment. It's also an SD-WAN, high quality of service that goes through. As soon as this comes online, so it turns on, with either an internet connection, so 443 as a outbound, no ports have to be open, so long as there is an internet activity, or you have 4G LTE, then that will come up to our cloud-based orchestration layer. It turns on the device. It has about 6 minutes PKI encryption. It then will say, you now send data from here to the virtual inode, which is located in the cloud. That's not our cloud. That's AWS, Azure, Google, or it's a client cloud. From that, we now start sending data up. We don't read the data. We don't store the data. We don't monetize the data. We do nothing with that data. Think of us as FedEx. We pick the data packet up, we deliver the data packet out. What we have built here on the integration part is an incredibly strong integration protocol down here to talk to 232, 485, Modbus, BACnet data, SCADA, CAN bus, PLC, OPC, whatever kind of communication that you need down there. Then at the top end, customers are wanting to have a data lake. So we have one particular customer that has thousands of sites across the world. They want to know what each of these sites is doing at any one point in time. That now comes into their data lake, and they're actually able to work out in real time what's coming through. Building analytics, industrial analytics, aviation analytics, whatever kind of analytics you want, you then as the customer can actually bring that in. The last thing on this slide, which is important, is our app store. We provide the infrastructure. We don't provide the solution. So now you may say you want to have ThingWorx deployed down on this hardware asset. You go to the App Store, you say ThingWorx, you put your license in, that comes down. Within 2 minutes, that application is sitting on the edge. If at a point in time you want to now change that application or add another application to the same data stream, you can now add another application in. So we've heavily invested into attracting some of the biggest brands out there who want to sit into our ecosystem, as well as other companies who now their core go-to-market strategy, they don't want to invest into all of this, so they say, we want to build our own bespoke software, put it into our cloud, and then that's their go-to-market channel. So the ioTium value proposition, there's a lot on this slide, but if you think about it in simple terms, you would have to get a firewall, you would have to get a router in place, you would have to configure VPNs, You would have to manage those VPNs. You would have to set up passwords for thousands of different sites. You would have to have a Cisco certified engineer involved into the deployment and the operation and the maintenance of it. You would have to call the IT department to talk about which ports need to be opened up to drive traffic out. With ours, we sell this as a managed service. We ship the inode. If the inode, the physical gateway unit, if that fails, we replace it. If it becomes end of life, we replace it. It's just a monthly fee that goes on in that infrastructure. We drop that, and there's a great example of a manufacturing, they make pasta in Nigeria. It's a production floor. We had that connected up into the cloud with a new protocol that they were doing. We didn't send anyone to Nigeria. We sent the local guys connected into the PLC, and that was them communicating to the cloud. This is a highly scalable solution, sold as a managed service. Just one thing there as well is on that right-hand side of the data lake, if you think about all the various platforms that are out there today, we now have the ability to send to AWS and to Azure and to Google Cloud with the same data stream or segmented data stream out from different subsystems. So for the customer, they only need one physical box at the asset level to be able to take the data to wherever they need to. So what we've invested into over the last years is the core software, right? So that is our platform, that is the operating system that is in place, that is the ioTium orchestrator in the cloud and the operating system. The hardware, we are agnostic. We will work with anyone. Companies come to us all the time to say, can you use this or can you use that? We're not better to that. And as I spoke about the App Store, what we've then done is we've said, where are the biggest roadblocks to wide-scale deployment? A big part of it is that digital transformation journey. So in this side here, we've gone to the 4 top large advisory services in the world to say, you're strong in digital transformation, you're driving change, here's a solution which will help you accelerate that, plus also you can make a heck of a lot of money on the advisory and the consulting, not only at the front end, but on the implementation. We also have technology implementation partners which just physically go and put the box in, put the cable in, connect it out. At the OEM side, if you think of brands like Siemens, Honeywell, Schneider, Rockwell, ABB, they all face the same challenge. There's this technology gap. That's not their core competence, it's not their core. So we're able to work with these companies to solve their technology gap and to complement what their strategy is. This is very hard to see, but that's MindSphere. MindSphere is a Siemens platform which takes in data in the industrial world and turns that into business insights. One of Siemens' big challenges is how do you get data from that PLC into MindSphere in a highly scalable, cost-effective model. I'm sure you're all familiar with Splunk. Splunk has the same idea. How do you drive analytics? They want to focus it on the industrial world. This cloud-based analytics is growing and growing and growing all the time. We have customers come to us with a very specific use case. We either know who they are, we can set them up. We don't monetize that green, we just connect people up to actually prove out that business insight. And the last part here is whether it's one of the big 3, it's a hybrid cloud or it's a co-location, we're able to put that data to wherever you want to go to. So within this, we now provide that entire ecosystem for someone to drive digital transformation, even if they don't know what they want to achieve. We have a customer in Switzerland. They have many sites. They want to build a data lake, but they actually don't know what they want to do with that data lake today, but they know they need to start collecting that data. So their first step is, let's connect the sites and the assets so that we're able to start to make informed decisions at a point in the future. Because if they delay this for 3 years until they work out their strategy, they've lost 3 years of collecting that data. So we have 3 core offerings that are all into the same box, all just turned on from a click of a mouse button. OTNet. OTNet connects devices to the cloud in a highly secure way. Connects it up, within 6 minutes we can have commuting to AWS. OT Access is where we now provide the secure infrastructure for an operator who's sitting down here to connect to a rig anywhere in the world under a controlled environment with full audit capabilities of what that service technician has done, and it will give a log. So we can lock down to say Jason from Siemens is able to access the Siemens PLC system operating in the North Sea between the hours of 9 o'clock to 12 o'clock on Monday, Wednesdays and Fridays. It's the same infrastructure, we're not adding anything else into it. The last one here is the OT Edge, where we talk about the applications. We are now able to deploy an application on an asset, and it could be Schneider wants to deploy on their infrastructure a particular application that they've built out to pick up something in the oil and gas sector. Again, this is totally open as far as that app store. We invite people to come into it. It's based on a Kubernetes structure, so it's not ours, it's an open, easily accessible, cost-effective means of deploying software. I'm going to finish on 3 case studies. Rexnord is a manufacturer of large gear drives. They're based in Milwaukee. They have a focus from their CEO to have all of their equipment, from these large expensive gear drives down to small bearings which go into manufacturing facilities or into mine sites, to have condition monitoring. Condition monitoring, what that means is they want to know what the oil temperature is, what the vibration is, what the temperature of the asset is, what the levels of water or oil or fuel, and the harmonics of how that's running. They want to collect that and they want to run it as an edge application to understand, is that device being used the right way? There's a local light that just goes green, yellow, red as an alarm. There's also SCADA systems, and there's also the cloud system. So they're now able to go into where a $25,000 device might be driving a multi-million-dollar mining operation. We can actually start to see ahead of time, is this device running quickly? Our technology is now fitted to all of those gear drives that come to the factory. Emerson, a facility down in Austin. Guys were having to go in and physically do the diagnostics on this. They're actually having to physically go into the building. Now, they're actually able to do it through the mobile device, actually see what the plant is doing in a secure environment. Lastly is a bank. The bank is focused on actually improving the occupancy and the utilisation of their sites. They've got 200 corporate offices around the world. They want to know what desks are being used when, because if they shift from 75% occupancy to 85% occupancy and are able to reduce their footprint as a result of it, they'll save $65 million a year. By us going into that site, in each one of those sites, they are now able to connect in IoT sensors which would not have passed the bank's security corporate network structure to actually take that data out. We're not providing the answer, we're providing the infrastructure. We're not providing the analytics of the cloud, we're providing the data that gives that data. Last one there is Siemens MindSphere. So this is taking millions of data points at any one time, pushing that through, working out what data needs to go to MindSphere. The cost model of MindSphere is data ingestion and compute. If we can switch a lot down to the edge, it actually makes MindSphere more cost effective for the customer. So hopefully that gives you an overview of ioTium. Thank you very much for the opportunity. I will take any questions.
Jason, I have a question. I know that network security is really critical in your implementations, and you're dealing with all these really nodes that are all over the place, IP addresses, Ethernet station addresses, etc. Do the traditional network management platform providers, for example, Hewlett-Packard, do you ever see them as a viable threat, or who would be some of your competitors?
So that company, as an example, is talking to us about how they deploy applications. So we may use infrastructure and partner with them on the hardware infrastructure, but they're actually talking to us about how they tackle these edge compute. So that could be a competitor. At the moment, they're enabling us.
What about others like F5 Networks and others that have been active in application layer network security and things like that.
So I think if you just fit at the network security layer, there are going to be multiple competitors at that part. But if you look at then the ecosystem of having the edge compute, the remote access, and then the cloud connectivity, at the moment there's no one in the world that's doing all three. So they may compete in a small part, but it doesn't solve the customers in problem.
Yes.
This might be a dumb question, but I'm trying to understand who's your customer? Like, who do you need to sell to? Is it the CIO at these companies, or like who's making the decision?
Yeah, so it's an interesting one. So I'll give you 3 examples. Here, Chief Digital Officer came in, he was charged with enabling the vision, condition monitoring and everything. So the CDO created a team, they built out an architecture, and they said, this is a gap, we can't build this in-house, or we could, but it will take us 3 years, and it will cost us too much money. Here, it was actually the process automation head who said, we need to improve the optimization. To get penetration though within Emerson, the head of security, CISO, he was the person who really at the end was the key, let's say the key hurdle to move forward. In here, we worked with the IT team to really focus in on what was the problem, what was the barriers, and to work with them. But at the end of the day, it was the global head of property who said, this is the way forward to go forward. So what we've seen is you need a combination of IT, OT, and a little bit of the business driver inside.
Can you talk a little bit about the edge node? There's lots of different formats of data coming in, and so what kind of formats do you cover? And second, how is that access set up? Since such a broad variety of edge nodes out there.
So if you think about, make it simple, right? So say this building. So there's a heating and cooling system, there's a lighting system, and so there's a security system. They're all connected onto a network, and it's a converged or a non-converged network. We connect in to those RJ45 to actually have that native communication, and then we will take backnet data from the building world to then say, read that backnet data on the edge, and then the application will then interpret that data into something. I'll give you an example of Honeywell. Honeywell has what's called a Niagara framework. They run that application within the building, and they can turn that data into something meaningful. So it relies on having an application to turn that data into something meaningful to have edge compute. That's where we work proactively with different organisations to help them turn that into something.
So the API is a standard API for TCP/IP?
TCP/IP, yeah. But backnet data, backnet IP data, but we have 405. We have, so Modbus is largely 405, 232 communications and some. So we'll take that data, and then the operating system that we've built can take that and then turn that data stream into something. One thing that we do is a little bit of the secret sauce is we don't manipulate the data from the entry point to the exit point. So we're not doing time series data at the edge, but keeping it as was intended at the start and pushing that. So we're not converting it on the way through.
Thank you, Jason. We are